Hi everyone, this tutorial video is going to offer you some more examples with how to add and subtract rational expressions. So the first problem that we have here is 2a all over a squared minus 2a minus 8 plus 3 all over a squared minus 5a plus 4. So what we want to do here is, just like we would with any other kind of fraction, addition or subtraction problem, we want to make sure that the denominators are identical. So as you can see here, we do have mismatched denominators, so we need to go ahead and take some time to fix this. So the way that they are now, we can actually go back to our skills that we learned and kind of honed in Chapter 5 and factor down both of these denominators. So I'm going to go ahead and basically do the factoring underneath first, and then we'll go ahead and we'll clean up the work. So I'm going to go ahead and use the guess and check method here in order to get this work done. So the first thing that I'm going to note here is I do have an a squared, so I can put an a and an a here. The next thing that I want to note here is maybe let's talk about the signs that are happening between these two. So I know that I do have a minus sign here, and so right off the bat I can comfortably say that there will be a plus in one and then a minus in the other expression. So now we should go back and take a look at the 8. Well, we need to think of a way that we can break apart the 8 so that our two numbers will multiply to give us a negative 8 and will add together to give us a negative 2. So to the best of my knowledge, and what I would maybe suggest doing would be to pause the video and go ahead and factor both of these denominators down and check your outcomes with mine. But the best outcome that I can come up with would be to use minus 4 here and put a positive 2 here. And remember, we can check our work here really quickly. We could do our outers, so that would give me negative 4a, and then our inners, which would give us positive 2a, which comes out to the negative 2a, which is in our middle term. So that looks good. Go ahead and clear that out so we don't have so much all over our paper. All right, so the next thing that we're going to go ahead and do is we're going to do the same thing for our other denominator. Let's see if we can factor this down. Again, we do have an a squared, so a and a. And this time I have a plus 4, but I have a minus 5. So the fact that my two values should multiply together to give me a positive number, but add together to give me a negative, tells me that both of these expressions will have minus signs attached to them. Okay, so now let's go ahead and spend some time on 4, and we need to figure out a way to have two numbers multiply together to give me 4, but add together to give me 5. And I ended up coming up with 4 and 1. And again, we could check this and we can verify that this is in fact correct. So my problem is going to go through a little bit of a remodel. So right now I have 2a over, and I'm going to put the factored version of my quadratic down here, plus 3 over a minus 4 times a minus 1. And again, the order at which you're writing these factors in the denominator, they do not matter. So the next thing that we want to note here is we want to find a common denominator. Well, one of the first things that I want to note here is notice that both of them already have an a minus 4 in there. But that's where the similarities stop. But that doesn't mean that I can't fix this. So notice here I do have an a minus 4, I have an a plus 2, but I don't have this a minus 1 here. So what I can do then is I can simply give it to it. So I will put an a minus 1 down here, but in order to maintain that exact same value of that fraction, if I'm going to give the denominator an a minus 1, I do have to give the numerator an a minus 1 as well. So essentially what I'm doing is I'm multiplying this by a glamorized 1 in order to make this fit for me. So we will go ahead and deal with that in a moment. And again, what I want us to note here is that I do have an a minus 4, I have an a minus 1, but I don't have this a plus 2. So in order to make this second term have an identical denominator, I have to multiply the top and the bottom by an a plus 2. So now we're all set to go ahead and continue to clean this up. So I'm going to go ahead and do this a little bit along the lines of a longer way, just to show you, and then as you get more comfortable, you can start kind of presenting your work in a little bit more of a condensed and efficient way. So I'm writing down that common denominator underneath both terms. And again, it really doesn't matter what order you write them in. I just chose to write them in this order. So in order to fix the top here, I do need to distribute that 2a to each of those terms. So right now I have 2a squared minus 2a. And I have to do the same thing over here. I have to distribute that 3 into that quantity of a plus 2, which is going to give me 3a plus 6. And now what I'm going to basically tell you here is more so for subtraction problems, but again, just to indicate to you that this is consistent. I'm technically doing plus the quantity of 3a plus 6. Now, in this case, we would distribute a positive 1 to each of those terms, and again, as we had seen in Chapter 5, distributing or multiplying by a positive 1 isn't going to change that expression. So we don't really need to show this part, but so we'll go ahead and we'll just carry on with what we have. So now what you can do, after I move this up a little bit to give me some more space, is now that we have a common denominator, I'm going to go ahead and just write this out all over that common denominator. So I'm just merging them together because now the denominator is the same. So right now we have the 2a squared minus 2a plus 3a plus 6. And basically at this point we're done with the denominator. It's just going to follow us through for the rest of this because it is part of our answer. We don't want to ignore it here. But we can clean up and see if we have any like terms. And actually I'm seeing my two middle terms here are like. So when all is said and done, we will have the a minus 1 times the a plus 2 times the a minus 4. The 2a squared does not have any like terms with it, so we will leave that. The negative 2a plus 3a will result in a positive a, and then again the plus 6 does not have anything left to combine it with, so it doesn't have any like terms to merge with. So at this point, what you would want to do is you would want to go ahead and take a look at the numerator and see if you could factor it down any further. For the sake of time, I will tell you that you cannot. So this is our final answer. Okay, so let's take a look at one more. So let's come on over to my other problem here. So here we have x plus 2 over 6x minus 42 minus x minus 3 all over 5x minus 35. So one thing that I want to note for you here is that you could turn this into an addition problem and it might actually save you from making a sign error. Actually what we're seeing here is we're seeing a subtraction of x minus 3. So we could rewrite this problem as follows. We could have x plus 2 all over 6x minus 42 plus a negative x minus 3 all over 5x minus 35, which again we could rewrite as follows. X plus 2 all over 6x minus 42 plus a negative x plus 3 all over 5x minus 35. Again, that's because we distributed the negative to each term that we're seeing here. Okay, so the next thing that we want to do is we're going to go ahead and focus our attention on our revised or rewritten problem. And I'm going to focus my attention on the denominators again. So at this point, we do have x plus 2 all over. We can pull out a 6 to give us 6 times x minus 7. And then we have plus that negative x plus 3 all over. And we can try to factor this one out. And we can see that we can pull out a 5, which would also leave us with an expression of x minus 7 inside. So again, we do want to go through and check to see what they have in common and what they do not have in common. And we actually want, that's what's going to help us find that common denominator here. So in this situation, then, I see that they both have an x minus 7, but this one is missing a 5 in its denominator, and this one is missing a 6 in its denominator. And again, we want to multiply the top and the bottom with that same number because we don't want to change the value of the fraction. We just want to change its exterior so it will allow us to combine those two terms together. So another thing to note here is that we do want to distribute the 5 to the x and the 2, and we also want to distribute that 6 to the negative x and the positive 3. So here's what we will now have. To save us a little bit of time, we will have a common denominator of 30 times x minus 7. Since these two numbers are relatively easy to combine, I went ahead and combined them. And then on top, we will have a 5x plus 10 plus a negative 6x plus 18. Okay. So again, we can go ahead and combine our like terms where we see them. I do see that I have a positive 5x and a negative 6x. So that is going to leave me with negative x. And then I also have a positive 10 and a positive 18. So that's going to give me positive 28. And that's going to be all over that denominator of 30 times x minus 7. Now, here is where your final solution is. Technically, if you're thinking about what we had done in previous classes, we could factor out that negative, which is perfectly fine. Then you could have rewritten your answer as, again, writing with that denominator. If we pulled that negative out, that would leave us with x minus 28. So as you can see, they are actually the same answer. One just has a negative factored out. And the other one does not. In this case, since it really doesn't help you reduce anything down, it doesn't matter which one you pick to help you out here. So I hope this video was helpful. If you do have any questions, please let me know.